Hello everyone and welcome back to Challenging Luck, where as usual we challenge luck. Today we'll be looking at a game of dice. This is a trick that you can use anywhere to win any game of dice. So, the game goes like this. You're at a bar drinking beer, eating some chips, and the bartender offers you if you want to play a game of dice. And you agree, and this game only has one rule. You either roll again at a 6 or at a 1, and you will add the number to the previous one, and whoever ends up having the largest number in the end will win the game. So let's look at an example. The first person rolls, they get a 6, they chose before the game started to reroll at a 6 rather than a 1, they roll again and then they get a 5. Sure, they have 11 now. The person in the right rolls, they get a 1. They get to reroll again because they chose to reroll at a 1, and then they get a 3, so they have a total of 4. So the person in the left, in this case, would win. So the question is this: would you choose to reroll at a 1, or should you choose to reroll at a 6 in order to win? And if you want to think about this question for a little bit, feel free to do so. And here's the answer. You should always choose to reroll at a 1. And in order to prove you that this is actually the case, we will do the simulation where we repeat this 100,000 times, as well as go to an explanation as to why this is the case. Just like last time, I wrote down the assumptions here. You reroll at a 6 or you reroll at a 1, that you add that number to the number that you first got. So the first thing that we'll do is define a function which rerolls at a 6. And we will use this every time to add the numbers. And here we want to pass in a starting value. This will be an integer, and we will be using this when we call this function recursively. So the first part is really simple. We roll a number and we select a random integer between 1 and 6. Very simple. Now here comes the tricky part. What happens if we roll a 6? Well, if we roll a 6, so if roll number equals 6, we want to call this function again. Why? Because we want to roll again. So what do? We return reroll at 6, and we pass in the number that we just got. So we just pass roll number. And otherwise, if we didn't get a 6, we will just return the starting value plus the roll number. So what happens here? Let's just look at this function for a little bit. In this case, if we call this function, we would probably call this with a 0. Then if it was a 6, it will call this function again, get a new number, and add those two numbers up if the first one was a 6. So let's just try and call this to make sure everything works. So let's say print reroll at 6, and we again always want to start with 0 here. All right, that's good. And just use Python 3. So in this case, we got 2, 3, 11 in this case. So the program seems to be working just fine. And now we need to do the same thing, but we need to do the rerolling. We need the rerolling to happen at 1. I'm not going to write this whole thing again. It's a very similar idea. We're rerolling at 1 now. We're still choosing values between 1 and 6, but now we roll again only if the number that we get is 1. So far so good. It all makes sense. And now that we have this function, everything else should be pretty simple, to be honest. So let's just try a case just to make sure everything is working. So let's say player 1. So this is the player that will reroll at 1. It's gonna be reroll at 1, and then we call this with 0. And then player 6 is gonna be the player that rerolls at a 6. Alright, now let's see which one will win in one case. So pretty simple. So if player 1 has a bigger number than player 6, then player 1 has 1. So this is just one case, one scenario. Let's save it and run. So player 1 1, player 2 1, player 1 1, player 1 1, so on and so forth. But again, we cannot do this for small numbers. We have to do this for large numbers. So just like last time, we will count the number of times that player 1 wins. So let's call wins for 1. And let's make this equal to 0. And let's say wins for 6. And let's make this equal to 0 also. Alright, and we want the number of repetitions here. And we want the number of repetitions to be 100,000 as usual. So now here we just have a for loop. So for I in range 0 to repetitions, we want player 1 and player 6 to be assigned the numbers when they roll. So this would be one game. So every time we're counting one single game. Here we say that if player 1 has a bigger number or bigger score than player 6, then player 1 wins. So we count that as a win for 1. So win for 1. And then we do the same thing, but now we do it for player 6, and I'll just copy this. And we can just reverse this. So if player 1 has a bigger number, then wins for 6 is grown by 1. And there is one more case that we should cover, and that is ties, because ties can happen in this game. So ties are 0, and that will be in the case if player 1 and player 2 have the same number. Then ties will be plus equal 1. Alright, so that's the code. It's pretty straightforward. All we need to do now is print the percentage wins for 1s, for 6, and the number of ties. So let's write this down. Wins for 1 will be wins for 1 divided by number of repetitions times 100 to get the percentage. And oh, I forgot the comma there, sorry. And let us add the percentage sign as well, just so we make this good looking. All right, so we have the win percentage for 1. Now let's do the same thing for win percentage for 6 and for ties. So win percentage for 6 will be wins for 6 divided by number of repetitions times 100. And the last one will be ties. So tie percentage, which will be equal to ties divided by the number of repetitions times 100. So let's see what we get. And you might be surprised, as I was the first time when I looked at it. Actually, when I first did this problem, I thought that I had a bug in my code, because as you can see, 1 wins 51% of the time. The reroll at 6 will win only 35% of the time, and then there will be a tie around 13% of the time. Let's do this again just to make sure we didn't, it wasn't a fluke. Again, very, very similar numbers. Flukes don't really happen when you're doing something, as often as we did 100,000 times. So let's go to a little bit of explanation as to why this is happening. So to understand why this is happening, let's look at the case when there are no rerolls. So what happens if you're playing a game with no rerolls for either player and you get a 1? If you get a 1 with a game with no rerolls, your chances of winning are 0. Why? Because 1 cannot beat any number and it will only tie with 1. And what are chances of winning if you get a 6? The chances of winning if you get a 6 without rerolls are 5 out of 6. Why? Because you can beat any number between 1 through 5 and you will tie with 6. So this is without reroll. So let's look at what happens now when you add reroll in the equation. So let's call this with reroll and let's see what the chances are in this case. So let's start with the easy scenario, which is 6. So 6 in this case will beat almost every number. The only number that it might not beat is 1 with a combined reroll of something. So like, let's say you get a 6 and then you reroll a 1 and the other player rerolls 2 1s in a row and then a 6. And in that case, the player that chose to reroll at a 1 would beat the player that chose to reroll at a 6. But how often does that happen? Well, for that scenario to happen, the chances would be 1 over 6 all to the third. So it would be 1 over 6 to the third. And the chances are quite low. So what happens here is that 6 will win almost 100% of the time if you reroll a 6. So the chances for 6 went from 5/6 to 100%. And let's see now what happens with 1 with a reroll. They had the chances closer to 0, right? But the chances for 1 now are increased much, much more. Why? Now with a reroll, and if the other person is rolling at a 6 and you're re-rolling at a 1, you'll always be able to beat 1. It's pretty simple because they get 1, you get 1, but you get to go again. It will always beat 2. Why? Similar thing, if they get a 2 but you get 2 1s in a row, then you get to go again. If you don't get 2 1s in a row, it will for sure be a number that's bigger than 2. And it will beat 3 way more often that it will not. Why? Because if they get a 3, first of all, you have a 3 out of 6 chance of getting numbers 4, 5, or 6. And if you get 1, then those chances increase even higher because a 3, 4, 5, or 6 would beat the other person. So the chances of beating 1 to 3 are pretty high, as well as chances of beating 4 are around 50%. So what this would do is that it would take chances for 1 to win a game to be over 50%. So now let's look at why it's more beneficial for you to reroll at a 1 versus reroll at a 6. If you look at how much better 1 got versus how much better 6 got, you can see the difference. So for 1, your chances went from 0 to over 50% of winning. So you saw that big increase. But for 6, it was 5 out of 6, which is around 80 to 83% to 100%. So it increased by 18 points. So you can see how you increase your chances of actually winning if you reroll at a 1 versus rerolling at a 6. Oh, sorry about that. This code will be in GitHub, and I would suggest you take a look at it, run it for yourself, and you can play around with it some more. And one thing that I'd ask you to do is to see what is the average number of rolls if you reroll at a 1 versus rerolling at a 6. Is it equal? Or overall, will you get a higher number if you reroll with a 6 or if you reroll with a 1? If you know the answer, please let me know down in the comments. I hope you enjoyed the video, and we will see you in the next one. Thanks.